Hello everybody, welcome into another lesson. So today we are going to talk about arithmetic sequences. So yesterday we introduced sequences and what they are. Now there are several types of sequences. In this course we will only cover arithmetic sequences, which we'll cover today. In another lesson we'll cover geometric sequences, which is another type, but in future courses such as Calculus 2 and discrete math and differential equations, some of those future courses, there will be harmonic sequences, power sequences, exponential sequences, you name it. There will be all kinds of other ones that require more advanced math knowledge to be able to figure out. So an arithmetic sequence is a sequence in which every term has the same common difference between them. So here's an example of an arithmetic sequence. So you have the sequence 1, 3, 5, 7, 9. If you notice, between each of these terms, they go up by 2, right? They go up by 2 more numbers. So you could say the common difference is 2, denoted by D equals 2. That's the common difference. Then we have an example of a non-arithmetic sequence. We have 3, 9, 11, 78, 82. So between 3 and 9 it goes up by 6. Between 9 and 11 it only goes up by 2. Between 11 and 78 it goes up by 67. And then between 78 and 82 it goes up by 4. So definitely not an arithmetic sequence because they don't have a common difference between them. It's all over the place. So let's do some examples of arithmetic sequences here. We're going to find the formula for an arithmetic sequence. Alright, so here is that first arithmetic sequence example. We have 1, 3, 5, 7, and 9. Well, is it an arithmetic sequence? Let's look at this. 1, 3, 5, 7, 9, and it keeps on going. Notice between each of the numbers, it has a common difference of 2, right? So that makes it an arithmetic sequence because it has a common difference between each of the terms. Now, we need to find a formula for this sequence. In general, I'm going to write this here. Formula for arithmetic sequence. So here is a formula to find any term of an arithmetic sequence. So it's going to be a sub n equals a sub 1 plus the quantity of n minus 1 times d. So the formula for finding the nth term of an arithmetic sequence is equal to your very first term plus the number of terms minus 1, all that times d, your common difference. So let's try to find a formula for this arithmetic sequence. So you have a sub n equals, well, a sub 1 is 1 plus, then we're going to have n minus 1 because it's an infinite number of terms times your common difference of 2, which we know we can distribute that 2 and simplify this. So that would equal 1 plus 2n minus 2, which means the formula for this particular arithmetic sequence would be 2n minus 1. So that's the formula for the nth term, is a sub n equals 2n minus 1. Now, we're being asked to also, let's find the 25th term. We're going to find a sub 25. Now, one way to do it, you can sit here and list out the first 25 terms if you really want to, but who on earth wants to do that? You have a nice shortcut here for the nth term of this arithmetic sequence. You're just going to take 2 times 25 minus 1. So that would equal 50 minus 1, which means the 25th term of this sequence is going to be 49. So with the formula for the sequence, you get that the 25th term of the sequence is 49. And I got more. All right. We have 6, 14, 22, 30, 38, and it just keeps on going and going. Well, let's look at this sequence. So 6 to 14, it goes up by 8. From 14 to 22, it goes up by another 8. From 22 to 30, it goes up by yet another 8. And then from 30 to 38, it goes up by another 8. Well, that means we have a common difference of 8 between all the terms. So your common difference would be D equals 8. That's your common difference, which means it is an arithmetic sequence. Now let's find the formula for this sequence. So the formula for the nth term, a sub n, is going to equal, again, a sub 1 plus that nth term minus 1 times your D, your common difference. So let's plug all this in. A sub n equals, your a sub 1 is 6, that's your first term, plus the quantity of n minus 1 times your common difference of 8. Which is going to end up then, if we simplify this, you'll get 6 plus 8n minus 8, which would have to mean that a sub n equals 8n minus 2. So that is the formula for the nth term of the sequence. A sub n equals 8n minus 2. Let's find the 50th term this time. Again, you sure as heck don't want to sit here and write out 50 terms, do you? That's going to take you all day. So let's put that into our formula. So that would be 8 times 50 minus 2, which would give you 400 minus 2, meaning your 50th term would be 398. So the 50th term of this particular sequence would be 398. All right. Here's a good one. We have 1/2, 3, 11/2, 8, and then 21/2. And then it keeps on going and going. So we have 1/2, 3, 11/2, 8, and then 21/2. Let's see if this is arithmetic. Well, between 1/2 and 3, what's the difference? Well, 3 is also 6/2, right? So it goes up by 5/2 between 1/2 and 3. Now, what about between 3 and 11/2? Again, that's 6/2. It actually goes up by another 5/2. So far, it's looking arithmetic. Now, between 11/2 and 8, well, 8 is 16/2, so yes, it actually goes up by another 5/2. And then between 8 and 21/2, well, it's 16/2, so yes, it actually goes up by another 5/2. So this would be an arithmetic sequence because you have the same common difference of 5/2. So the common difference would equal 5/2. Now, let's find the general formula for this sequence. So a sub n, that equals your a sub 1, which is 1/2, plus the quantity of n minus 1 times 5/2, which means we can simplify this. So you'll get 1/2 plus 5/2 n minus 5/2. So what you really end up getting here is a sub n would equal 5/2 n minus 2. Because 1/2 minus 5/2 is negative 4/2. This would just be 5/2 n minus 2. So that is the formula for the nth term of the sequence. Alright, now, let's find, you ready for this? The 200th term. We're going to find the 200th term of the sequence, a sub 200. And again, I don't think you want to sit here and list out 200 terms. No one's got time for that. So we'll put in 200 for n. That'll be 5/2 times 200 minus 2. Alright, so let's see. That would be the same as 5 times 100 minus 2. So that would be equal to 500 minus 2, which would give you 498, which would be your 200th term. So the 200th term of the sequence would be 498. So it's very nice with arithmetic sequences that you can do these shortcuts. Very, very nice. Let's do one more example of this, then we're going to do a final type of problem for this lesson, then the lesson will be over. Alright, now, good. So we have 1.6, 4, 6.4, 8.8, and then 11.2, and then it just keeps on going and going. So you have 1.6, 4, 6.4, 8.8, 11.2, and it keeps on going. Alright, well, let's see if we could figure out if this is arithmetic or not. Between 1 and 6, it increases by 2.4, right? Then between 4 and 6.4, it's going to increase by another 2.4. And then between 6.4 and 8.8, it increases by another 2.4. And then between 8.8 and 11.2, it increases by another 2.4. And it keeps on going and going in that pattern. So this would be arithmetic because the common difference is 2.4 between all the terms. So that means D equals 2.4. That is your common difference. Alright, now let's find a formula for the nth term of the sequence. So a sub n would equal your a sub 1, which is 1.6, plus the quantity of n minus 1, times your common difference of 2.4. So we can simplify this. You'll get 1.6 plus 2.4n minus 2.4, which means the formula simplifies into a sub n equals 2.4n minus 0.8. So that's the formula for the nth term of the sequence. A sub n equals 2.4n minus 0.8. Now let's just find the 10th term. We'll be tame this time. A sub 10 equals 2.4 times 10 minus 0.8. Well, that's going to end up then giving you 24 minus 0.8, which means your 10th term would be 23.2. So the 10th term of this sequence would be 23.2. Alright, so that is in general, when you have an arithmetic sequence, how you find the formula for the nth term of a sequence, and then you can find any term you desire by just sticking that into your value of n. Alright, now let's shift it a little bit here. We're still on arithmetic sequences, of course, but let's do something different. Now, we are given a sequence here, an arithmetic sequence, where the common difference is 4, but they give you the 14th term. The 14th term is 46. So all we know is the common difference is 4, and we know the 14th term is 46. We need to find the formula for the nth term. Well, in general, what is the formula for the nth term of an arithmetic sequence? A sub n equals a sub 1 plus that quantity of n minus 1 times d, right? That's the general formula for an arithmetic sequence. Well, let's go ahead here and... Will orange show up well? Oh, yeah, well, not the best. Let's try to use this marker here. Let's use green. So we know the 14th term, so put that in for a sub n, being your 14th term. We'll set 46 equal to a sub 1. We don't know what that is yet. So really the idea is first, let's solve for a sub 1. Then we have hopes of getting an equation or a formula for the sequence. So that equals a sub 1 plus the quantity n minus 1. Well, they gave you the 14th term, so 14 would be your n minus 1 times your common difference of 4. So that means 46 is going to equal a sub 1 plus 13 times 4. So that means 46 equals a sub 1 plus 52. So that means a sub 1 is going to end up then equaling -6. So your first term of the sequence is -6. We just solved for it. Now, to find the nth term formula, take a sub n equals your a sub 1, which is 6, or sorry, -6, plus that quantity of n minus 1 times d, which is 4. So that's going to give you, of course, -6 plus 4n minus 4, which means the formula for the nth term, a sub n, would be 4n minus 10. So there is your formula for the nth term of this sequence. A sub n equals 4n minus 10. And I got more examples like this. All right, what if, let's see. So another sequence where the common difference equals -12, because you can have sequences where it actually goes down instead of up for each term. We've seen that. The common difference is -12, and well, that's easy. They give you your first term is 80. They gave you the first term this time. A sub 1 equals 80. So we can go ahead and create the formula right away. A sub n equals your a sub 1, which is 80, plus that quantity of n minus 1 times that difference of -12. Well, this would turn into 80 minus 12n plus 12, which means the formula for the nth term of the sequence would be 92 minus 12n. So that is the formula for the nth term of the sequence. A sub n equals 92 minus 12n. So it's going to go down. That means your second term should end up being 68, and it should just keep going down. All right. Good one. So you have a common difference of 5/3, and then they give you the 8th term is equal to 24. So here's what you got. The common difference of this arithmetic sequence is 5/3. The 8th term is 24. We need to find, of course, the formula for the nth term of the sequence. Well, again, what is that form? It's a sub n equals a sub 1 plus the quantity of n minus 1 times d. That is the formula for an arithmetic sequence. Now, let's apply that to what we have here. Since we got the 8th term, we're going to have to solve for a sub 1 again before we have a prayer finding the formula for the nth term of the sequence. So we got the 8th term, a sub 8, which is 24, set that equal to a sub 1, plus now they gave you the 8th term, so you'll put in 8 minus 1 times that 5/3 quantity. All right, so what's that going to give you? That gives you 24 equals a sub 1 plus 7 times 5/3, which means 24 equals a sub 1 plus 35/3, which now we can solve for a sub 1. What is 24 in terms of a denominator of 3? Well, that's 72 minus 35, that would be 37/3. So your first term should in fact be 37/3, okay? Now we have a chance to find the term for the nth term of the sequence. So a sub n is going to equal your a sub 1, which is 37/3, plus the quantity of n minus 1 times your common difference of 5/3. So this will simplify into 37/3 plus 5/3 n minus 5/3, which would mean the formula for the nth term of the sequence would in fact be 5/3 n plus 32/3. So there's the formula for the nth term of the sequence, 5/3 n plus 32/3. All right. Let's do one more. All right, so we have one where the difference of this particular sequence, the common difference is negative 4.1. And then they give you the 16th term. So a sub 16 equals 48.2. All right, so we have the common difference of this particular arithmetic sequence is negative 4.1. The 16th term of the sequence is 48.2. So again, if it helps you, write out the general formula for the nth term of an arithmetic sequence. A sub n equals your a sub 1 plus the quantity of n minus 1 times d. So now we need to apply this. We got the common difference in the 16th term. That means we got to solve for a sub 1. So let's do that. We got the 16th term, a sub 16, which is 48.2. So that means 48.2 equals a sub 1 plus that quantity of n minus 1. Well, that's going to, the n will be 16, then minus 1 times your d of negative 4.1. So this means 48.2 equals a sub 1 minus 4.1 times 15. All right, so 48.2 equals a sub 1 minus, let's figure this out. Let's figure out what that a sub 1 is going to be. Well, 4.1 times 15, if you negate that, it's 61.5. So you'll end up having a sub 1 minus 61.5 on the right-hand side. So now we can literally just solve for a sub 1, which is going to equal the sum of these two numbers. So take that plus 48.2, so you get 109.7 for your first term. So the first term of the sequence is 109.7. Now we can find the formula for the general nth term of the sequence. So a sub n equals your a sub 1, which is 109.7, plus the quantity of n minus 1 times your d of negative 4.1, which would simplify into 109.7 minus 4.1n plus 4.1, which means your a sub n would end up equaling 113.8 minus 4.1n. So that is the formula for the nth term of this sequence. A sub n equals 113.8 minus 4.1n. So that's it for arithmetic sequence. Next lesson we will do arithmetic series. There are tricks for doing an arithmetic series as well. So I hope everyone has a great night. Take care.